All right, hey folks, Emily here. In this video, you are going to learn how to evaluate foundation models on SageMaker. So let's dive in. All right, so what does this look like? What's going on here? So foundation model evaluation is a new launch within Amazon SageMaker that lets you easily evaluate foundation models using both SageMaker Jumpstart and your own models that are built on top of SageMaker endpoints. There are a lot of capabilities in this launch, so let's understand this in some detail. So first off, you have two different ways you can work with this. That's both a wizard or sort of a managed web app that's directly inside of SageMaker Studio, and a Python library that's available such as through Jupyter Notebooks. We're going to look at both of those today. And then the model that you're interacting with is primarily, again, hosted on SageMaker, particularly if you're using the UI. However, if you're using the Python SDK, you can evaluate any model. So you can hit models in Bedrock, you can hit Cloud models, anything you want in the Python SDK. But in the UI, again, most of it is going to be SageMaker hosted models. Once you've picked the model that you want to evaluate, then you can determine the task for that. So that can be a general purpose text classification, or it can be summarization, can be question answering, and then classification accuracy. Once you've determined the task that you want to use, you'll look at the type of evaluation. And so in the web application, we have actually two components for you. One is sort of human-driven evaluations. You can set up labeling jobs using the UI. It's very easy to set up. You'll be up and running in a couple minutes, I promise. Once you set this up, then you can create label data sets, such as for instruction fine-tuning. You can use the human labeling in Studio, or you can use the automated evaluation that uses pre-built metrics. Once you've determined your type, you'll move into configuring this. And so you can use pre-built data sets that, again, are already available in the UI, or you can bring your own data sets. And then there are algorithms for these capabilities that are already built. And then in the human method, of course, you'll pick the method of evaluation and then bring your labeling teams to complete that evaluation. After that, you'll determine the dimension of evaluation that you like. So if you want to evaluate the models based on accuracy, robustness, stereotyping, toxicity, etc. And then once you've done this, you can get detailed reports. In the UI, we'll create PDFs for you. And so you can download the PDF from your S3 bucket, and then it's a really, really rich document with multiple pages of information about the most toxic prompts, for example, the least toxic prompts. We'll give you lots of charts that tell you in greater detail how your models are performing. And then in the Python library, which is what we're going to look at today, actually we're going to generate a radar plot that shows you how well your model is performing on a variety of metrics. And so how are we going to use this? How to use FM eval. So again, number one, select a model. Number two, configure your evaluation. So whether that's human or automated, and then set the dimensions, the algorithms for that, and then configure your job. So again, in the UI, that's going to run as a labeling job or as an evaluation job managed in SageMaker Studio, but running its own machine. Or if you're using the Python library, that's going to execute locally. So that's going to consume the notebook resource that is invoking that command. And then you'll store the results in S3. And so in this notebook, first off, we're going to, again, open up a notebook in SageMaker Studio. Then we're going to install the FM eval library using the open source repository. And then we will evaluate models on SageMaker Jumpstart. So let's dive in. All right, so let's take a look. So in this demo, again, we are going to install the FM eval library, but I want to show you a few endpoints that I already have created because the library is going to use those. So in particular, we're going to look at Falcon models. So we have Falcon 7B, so 7 billion parameters, in a Falcon sort of base model, and then one that's been instruction fine-tuned. And so both of these I've created ahead of time. The library is available over here. Actually, if you haven't seen this, take a look. Give us a star if you're feeling kind. And so in FM eval, again, essentially you can interact with evaluation capabilities just in Python directly through a really intuitive and easy to use interface. Essentially in FM eval, you'll import a variety of algorithms such as toxicity, and then create configurations for those. You'll create configurations for your dataset configs, so pointing to custom datasets such as in JSON lines, and then essentially applying that algorithm to the dataset and creating this model runner. So we're going to take a look at that in the example. So if you want to follow with me, we're in the examples repository in the examples folder. And then again, you have many examples here, such as evaluating Bedrock, Claude models, or again, ChatGPT, custom models in Hugging Face, and then of course models in Jumpstart. So I'm going to be doing the model comparison notebook, which looks at two models on SageMaker Jumpstart. Again, the base Falcon and then instruction tuned. So that is over here. All right. So first off, of course, we're going to import SageMaker, and then we're going to install FM eval. So it's just a pip install. And then the notebook is handy. It lets you test the endpoints. So you define your prompt with this payload here, and then again call predictor.predict to get the response back. It's interesting because it asks the same question to both models, which is nice. And then essentially this function takes the existing endpoint name. So you pass it an endpoint name, but if you don't have one, then it will actually just deploy one for you. The Jumpstart model deploy is really easy to use. So just in the Python SDK here, you can point to this Jumpstart model, pass it a model ID, and then it's really just model.deploy. So again, using the Jumpstart packages and pre-built images is really straightforward. And so we'll say model.deploy, and then that of course has an endpoint name. As promised, I did point to my endpoints already. So I have this Falcon base and then this Falcon instruct tune. And so both of those I loaded in, but you can absolutely use this to create them. After that, again, we'll do a pip install on FM eval. And then within FM eval, we'll pick a couple algorithms here. So first I'm picking the QA accuracy, so accuracy on question answering. That's the primary one we're going to evaluate. And then I'm also bringing this Jumpstart model runner. And so this model runner essentially is just a pointer to the model, really. We have the endpoint name, the model ID, the model version, and then the output format and the content template. So essentially that is really how the model receives information, right? That's essentially the format for the payload here. So that's this content template. So after that, we're going to run evaluation. And so this evaluation takes the model and the name, and then we're going to set up this question answering accuracy config here. And that is pointing to a local file. So fortunately, the notebook actually ships with an example of having run this ahead of time, which is really nice. That saves a good amount of time. So I pointed to that here. Otherwise, you can just run it from the notebook directly. All right, and so then we call this run eval function. Then again, I'm loading in the previous examples on both the Falcon 7B and then the Falcon 7B instruct. After that, we're going to visualize the results. So in those results, I'm importing Plotly and then loading the results right here. So again, reading from that file here and then just opening up the accuracy scores and the dataset scores. And then now we're going to put together that radar plot. So we're creating a radar plot, which we're going to see in a little bit here, that shows us the average performance over 3 datasets. And then we call the function here to actually generate the graph. And I know this is a little tough to see because I prefer dark mode in Jupyter Lab. So I have this visual for you right here. And so again, this is two models. So we have the Falcon 7B and then the instruct. And then essentially these are the different scores that we care about. So we have an exact match, recall over words, quasi-exact match, and then precision over words. And so this is interesting. Let me see if I can zoom in here, because on each of these metrics, you can see that the Falcon model clearly, the non-instruction fine-tuned clearly is better at recall over words, right? It obviously has an edge here, but on all of the other indicators, it's much worse. Actually, it's considerably lower because it's this blue relative to the red. And so it's just interesting to see that the instruction fine-tuning actually introduced a degradation on recall over words, but is, of course, much stronger, such as on F1 score, and then precision over words, and then the other two indicators as well. And so that's just one example of using the FM eval library. And then again, you can absolutely run this in SageMaker Studio as well. So in SageMaker Studio, to set this up, we'll just go over to Jumpstart. And then within Jumpstart, we'll pick our model, and let's say Falcon. And let's say we want to do Falcon, maybe 40B instruct, just for fun. And then you'll click Evaluate. And so again, Jumpstart keeps all of the evaluation capabilities here for you. And then I have a number of jobs for evaluation that are online. All right, so now let's look at the model evaluation in SageMaker Studio. So you can see I have a few jobs, and in particular, I ran a job to evaluate code llama, which I thought was fun. So of course, most of the time we think about coding language models as a way to get code. And so I thought it'd be fun to see how well a coding model could handle standard eval tasks. So things like natural questions, trivia, and then toxicity and things like this. So I set up this job, and then essentially, so again, this is using SageMaker Jumpstart and then model evaluation. And for each dimension, such as accuracy, toxicity, semantic robustness, for each of these, there are a variety of data sets. And then for each of these data sets, I have the score for a number of statistics. And this view that we're seeing here is essentially the shorthand result. It's sort of the abbreviated summary. What we're going to do right now is view the evaluation results, which is a PDF or Markdown file generated in your S3 bucket. So that is right over here. So this is my S3 bucket, my Code Llama eval report, and let's check it out. So here is my evaluation report. So again, for each task, it shows us the different data sets. So Bool, Q, natural questions, and then trivia, QA. And it's nice because each of these gives me the link. So if I don't know about Bool Q, I can go click on this link and take a look at this Bool Q dataset, which has yes/no questions for almost 16,000 examples. And then I can see the F1 over word score, my exact match score, and then so on and so forth. In most of these, higher is going to be better. I can also see semantic robustness, so how well the model responds to like minor changes in syntax while keeping the same semantic meaning. And then toxicity, of course, how toxic the model is. This uses a pre-trained toxicity model. And then the overall job config. And then here we go. So I love this report because it gives us a summary of what this means, what it's about, how we think about accuracy and question answering. And so the model is presented with a reference text containing the answer. And then in the closed book case, the model is not presented with anything but uses its world knowledge. So you have those two different settings. And then again, the summary on the data set. And then F1, telling us both what F1 is and the rating of that. So 1 is better for F1. All right, and then we also get the top 5 examples. And so did lava flow from Mount St. Helens? Model output true, and the target output was true. So in reality, it was true. And so that's your F1 score here. A couple other examples that the model got correct is just Chicago being the 3rd largest city in the US. And then false, which it also got correctly. So these are the top 5 examples with the highest scores. And then we'll also see the lowest 5 examples. And so in this case, the model did, so actually, interesting, it tried to say both. So we asked the question, is the Hunger Games based on Battle Royale? And the model came out with, actually it came out with this whole thing. So please select an answer, true, false. So it didn't decide, and the true answer was false. Is petroleum jelly the same as white soft paraffin? Same flow. So these were cases that the model just didn't take a stand, basically, and then was wrong. All right, and so this is what's in your evaluation report. This is a 228-page PDF document, and I love it because, again, you can do this with the pre-built data sets, and you can also do that with your own data sets. And to learn more about how to do that, check out my YouTube video on the series. That is a wrap. So thank you very much. Let me get you some resources. All right, so here's some resources for you. So again, the first link is just to learn about foundation model evaluation within Clarifai. So again, new launch that you can learn more about. And then this comes with a set of example notebooks, again, in FM eval. Feel free to check out my reInvent session on the topic with Mike Diamond. And there's also a dedicated YouTube series just for this library, actually, and for this whole space, such as preparing the data sets, bringing your own models, using the human labeling system, using the automated evaluation system. All of that is available in detail to watch. And so with that, thank you very much.